So as I said before, I want to, when I talk to adult learners and I talk to high school students and even middle school students, and I ask them, when do you feel like what topic took you out of the math game? And oftentimes they will tell me one of three topics. Top of the list is always fractions, and then multiplication facts often, and then long division is that third topic that students often say. And I will say that I want to provide an alternative, which is called the partial quotient algorithm. So, what is the partial quotient algorithm? I think the easiest way to talk about this is in the context of a problem. So, let's do 2,470 divided by 8. And I'm going to approach this problem. Since it's non-decontextualized, I'm going to give it a context. So, suppose that we have 2,470 marbles, and we're going to put those marbles into 8 pots. So we're going to approach this from a sharing perspective today. And we need to equally share those 2,470 marbles to those 8 pots or bags, whatever you want to think about it as. So again, the beauty of the partial quotient algorithm is a student can come in where they are. There's some flexibility. So let's suppose a student who really doesn't have a firm grasp on their multiplication facts come in and think, you know what, I can make 8 groups of 100. So I'm going to put 100 marbles in each of those pots. And again, I'm recording up above the 100. Again, my dynamics are a little bit out of place here. There we go. So again, the student recognizes I have 1,670 marbles left. You know what? I'm going to do that same thing again. And again, I'm going to record another 100. So now I'm up to 200. Guess what? I can do that again. So we're using a little repeated reasoning here. And now I have 300 and I've got 70 marbles still to place. And again, I'm not real confident in my multiplication facts, but I know what is accessible to me. So I'm going to move 5 to each one and I got 40. So now I have 30 left. Well, I know 8 times 2. I'm going to move 2 this time. And now I'm going to move 1 to each of those 8 pots. And I have 6 left over. So when I add all those up at the top, I have 308 marbles going in each pot with a remainder of 6. So again, it took the students 6 steps to get there, but they were able to use multiplication facts that they were comfortable using. And as they learn, again, they'll see, how to be more efficient. For example, they noticed they used 100 3 times, so that I could have done 8 times 300. But as they develop proficiency, as they start to see some of those relationships, they'll become more strategic in their choices. So I want to contrast that. Let's contrast that with another student. Different way, same problem. But now they notice, you know what? I can do 8 times 300. So I'm going to do that. I've got 70 left over. And I know 8 times 8 is 64. And I've got that 308 again in 2 steps this time. Now, I want to contrast that with the traditional long division algorithm. And I want to make a couple points. First of all, you'll notice that we were being very explicit about the use of our multiplication facts. So we're reinforcing the idea that division, there's this relationship between division and multiplication. And we're making that explicit by the fact that we're using our multiplication facts that we know to perform the division. Now, it's not my favorite terminology, but I'm going to use the traditional because when we start to think about division, we use different terminology. And we ask ourselves, using imprecise language, oftentimes, how many times does 8 go into 24? And that's not real precise language. Really, what we're asking is 8 groups of what is 24. Now, what's interesting here, what you see on the left is not 24. That is 24 hundreds or 2,400. And we see that over on the right-hand side. We see the 2,400. We don't see that here. It's not explicit. And when we write the 3, we typically write it where above the 100 because we're talking about 300. That's what we have. Now, again, this is a little wonky, but you brought the 7 down. That's typically our terminology. And how many times does 8 go into 7? Well, it doesn't. And that's typically, we put the 0 above the tens because we don't have any tens, although that's not made explicit. And then we typically bring down the 0. My 0 got there a little early on this example. So it's down there. And so now we're asking ourselves, we have 70 marbles, and we're gonna move them into those 8 pots. So again, not sure why we're doing that again, but we're doing it. And so we have 8 groups of 8 in this particular case. And we're not really, how many times does 8 go into 70? Again, not really liking that imprecise language because there's a multiplicative relationship there that we want to focus on. And again, we've got that relationship, same answer as we got. But again, I want to point out a couple things. First of all, that 24 in the traditional algorithm, we have to have a good sense of our place value. In this case, you're not seeing it. But on the right side, partial quotient algorithm, you're seeing it. It's explicit. It's related to the multiplicative relationship. There it is. And the same with the 3. On the left, the traditional algorithm, the 3, we have to have in our back pocket that's representing 300ths. And that's not explicit. Whereas over on the right side, it is. It's in our answer. Up above is 300, and we're taking 8 times 300. So it's explicit. And so again, I just wanted to contrast and give you a couple examples of the partial quotient algorithm and also contrast it with the traditional long division algorithm.